Hey, this is Physics 2211, lab number 4, dealing with oscillations. So starting off, we will have an introduction, which introduces the premise of this lab, then doing a motional analysis with tracker. We're going to find values to use in a computational model written in GlowScript. Lastly, we're going to analyze and answer some questions. So to start off, this lab aims to model the changes in energy and the 2D motion of a mass that is attached to a spring fixed at a point at one end. So this investigation found that the energy principle is in play for this model. So the key ideas at play are Newton's second law, which is the momentum principle. Also the energy principle and the kinetics update formulas are used as well. Right here, these are the formulas all written out. So this is the original video that is being analyzed. To start off, we're going to do a tracker analysis. Here are the steps below. The tracker software is going to track the point mass in the video, and showing its relative position at different times will allow us to create a model both in tracker and also to help out with the GlowScript. So here's the tracker analysis. This is the tracker model. As you can see in the top, the mass is set to 0.402 kilograms, which is the mass of this black mass right here. You can see at time 0, the initial position is right here, and these are the oscillation graphs, and we can see it in motion being tracked. And this blue line is also calibrating, setting it to 0.7. This is so the initial conditions. We have a couple different things we have to calculate here: the period, spring stiffness, and the relaxed length. So to find the period, I averaged 3 different periods, these 3 peaks right here, and it averaged out to around 1.519, and using that calculated the spring stiffness using this formula right here to find 6.83 as the stiffness, and the relaxed length was found to be 0.123 using the following formula. So on to the computational model. So onto the computational model. As you can see here, this is the GlowScript code to simulate the motion of the mass. Here's the mass of the system, and the initial conditions are here, the position, and delta t, the acceleration due to gravity, spring constant as calculated, the relaxed length of the spring, and then these are the energy formulas as put in the introduction. And this is the while loop, so it goes up until the last timestamp in the data, and then all of the gravitational force formula, spring force formula, net force formula are all inputted, the momentum principle as well. And then all of these formulas combined calculate the individual changes within each energy and then adds them up to do an energy update. Running this program, you can see using the data from my tracker, this is how it's shown. Now on the x-axis you can see that the experimental data lines up with the prediction, but there is a bit of a mismatch. It's the opposite direction in the y-axis. That is probably due to experimental error, which will be discussed. So the possible errors are that the y-direction graph is going in the opposite direction, so this is most likely due to an error in calculating the initial conditions or due to a minor error in the code itself. Since the experimental versus actual is pretty linearly shifted, it's not actually radically different, it's just shifted by half of the period length. The x values, however, are oscillating and they match as expected. So on to the questions. So the first, what does it mean question. The delta E is staying approximately at 0 the entire time, so this means that the energy principle is satisfied by our model. On to the next one. There is a difference of 0.094 seconds between the period in the x direction and the y direction. So this discrepancy may have been caused by errors in the tracker analysis point mass selection, or because of the angle at which the mass was released. This discrepancy causes errors when calculating the initial conditions, which has to be taken into account. Thank you.